Let's take a look at this example. This time we have D at the front of each term, and it means that D is going to represent the most significant bit. So you have to prepare your Karnaugh map properly in order to solve this expression. It means that DC are going to control the left side of the K-map. I call control. It means that we are going to place DC on the left side of the Karnaugh map and BA at the top. So BA, 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 and BA. And I have DC, 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 DC. Above zeros, we are going to draw the negation bars, okay? Anytime we have variable above zero or next to zero, you're supposed to write the negation bar. And I have D naught, C naught, D naught, and this is C naught. Highs are going to be placed in following cells: 0, 3, 4, 7, 8, 11, 12, and we have 15. Now we can create two groups. This is one group of 4, and this is another group of 4. This group is placed in one column and 4 rows. 4 rows. At the side of this column, we do not have any common variable for these 4 rows. Please notice we have C naught, C. They are complements. We ignore them. We have D naught, D. Complements. Ignore them. That's why we are going to ignore everything, whatever is on the left side for this group. And we are going to copy down everything, whatever is at the top of this column. At this moment, I have B naught, A naught. Or we have another group of 4, which is placed in 4 rows and 1 column. We said we are going to ignore everything, whatever is on the side, and copy down everything, whatever is at the top. So I have B, A. This is nothing else, just exclusive NOR. And this is B, exclusive NOR with A. If you want to implement this, this is single exclusive NOR gate with inputs B and A. These are the solutions to my problem.